Hi, for this video, we'll be looking into ohmic and non-ohmic resistance and the Ohm's law. So what's the Ohm's law? It shows the relationship between current, voltage, and resistance. So the Ohm's law tells us that the current passing through a conductor is directly proportional to the voltage and inversely proportional to the resistance, thus giving us the formula current is equal to voltage divided by resistance. Now, if we consider resistance, resistance is directly proportional to voltage and inversely proportional to the current, thus giving us an equation: resistance is equal to voltage divided by the current. And voltage is directly proportional to both current passing through a conductor and resistance. Thus, you have an equation: V is equal to IR. So that's the Ohm's law, showing the relationships between current, voltage, and resistance. Now, what is ohmic resistance? Electrical elements can have ohmic or non-ohmic resistance. So when a material or device obey the Ohm's law, then the material or device has ohmic resistance. So a resistor that has constant resistance obeys the Ohm's law, where current is directly proportional to the voltage. The current versus voltage graph for ohmic materials is a straight line with a slope of 1 over R. So that is your resistance that is affected by both voltage and resistance together at a constant rate, since it will obey the Ohm's law, where your resistance is equal to V over I, or voltage over your current. Then for non-ohmic resistance, on the other hand, these are materials that do not follow the Ohm's law. So the current is not directly proportional to the voltage. When the current and voltage are negative, there is a very small current, or zero, through the diode. And if the current and voltage are positive, then the current increases non-linearly. So as you can see there, the graph for the resistance of a non-ohmic material is not a straight line compared to, or if you are going to compare it to ohmic resistance or ohmic materials, where there is a consistent rate in between the changes in resistance as you increase your current and as you increase your voltage. So you have your sample problem. An electric flat iron draws a current of 15 amperes when connected to a 110 volts line. For A, assuming that the heating element of the flat iron obeys Ohm's law, what is its resistance? And B, what is the resistivity of the heating element if it is a wire that is 2.5 centimeters long with a cross-sectional area of 2 times 10 raised to negative 4 meters squared? So for A, we are asked of the resistance, and it obeys the Ohm's law. Therefore, if it obeys the Ohm's law, then R is equal to V over I. And what's the given voltage? That is 110 volts, and you are given your current, which is at 15 amperes. So you just substitute that. You have 110 volts over 15 amperes. Then resistance is equal to 7.3 ohms. So that's your resistance. For question B, we are asked of the resistivity of the heating element. If the length of the wire is 2.5 centimeters. If expressed in meters, then if it's expressed in meters, then that's 0.025 centimeters. And then we are also given the cross-sectional area, which is 2 times 10 raised to negative 4 meters squared. So how do we solve for the resistivity of the heating element? Remember that resistance is equal to resistivity multiplied by length over your cross-sectional area. So therefore, for resistivity, that will be equal to the cross-sectional area multiplied by the resistance over the length. So to solve for the resistivity of the heating element, that is equal to the cross-sectional area, which is 2 times 10 raised to negative 4 meters squared, multiplied by your resistance, which is 7.3 ohms from the previous question, divided by your length of the heating element, which is 0.025 meters. Therefore, the resistivity of the heating element is how much? 0.0584 ohm meter. So that's the resistivity of the heating element. So that's our quick video for ohmic and non-ohmic resistance, and an introduction, of course, to the Ohm's law. Thank you very much for listening, and see you on our next video.